Today we're going to be calculating probabilities using z-scores, looking at another variation, which is looking at two tails. So what we did last lesson is that we talked about finding probabilities around the center. So you have a negative z value here, and you had a positive, oh, that's not a very straight line, positive z value here. And we worked out the area between them. Today's it's only a slight variation on that, is what we're going to do is, rather than working out the red area, is what about these two tails on the other side? Can we work out the probabilities in them? And it's a very simple task, is that what we do is work out this red area and we take it away from 1. Because the whole graph adds up to 1. If we know the red part and we can get the red values from the table, we can work out this part of the table, and we can work out this part below the table. So once we can work out that part of doing that question, then we can just take it away from 1 and we've got our answer. So it's not really that much more difficult than we already know. We just need to be able to recognize it. And it tends to be that we talk about this area being greater than that z value and this being less than that z value. And it's not a continuous group like the red area is. So let's have a look at a question. But the reality is all the same steps still apply. So the example we've got is the weight of bags of washed potatoes is normally distributed. The mean is 2.5 with a standard deviation of 0.15 kilograms. What is the probability that a randomly selected bag is less than 2.425 kilos and is greater than 2.5825? Right, so first step, as always, draw the picture so you can see what's going on. So things we do know. We know that our mean is equal to 2.5. We know that our standard deviation is equal to 0.15. The next part is that we're looking is that it's our first Z value is 2.4, so it must be less than 2.5. So 2.425. And the key bit is that it's less than that. So it's this area here. And it's got to be greater than 2.5825, which is here. So that's the area we're trying to work out. Now, what we're going to do is we're going to work out this area, and we're going to work out this area, so that we can take that away from 1. And to do that, we're going to need the table, but first we're going to need to work out the z-scores for those values. So there's our calculation. So starting off with the blue, is we've got 2.425 take away 2.5 divided by 0.15 equals, which is minus 0.5. So in other words, this is minus 0.5. Now for the other score there, we're going to do 2.5825 take away 2.5 divided by 0.15, which is equal to, which is 0.55. Okay, now that I know what the Z values are, I can look them up in the table. So first thing is 0.5, so it's 0.50, which means that's 0.1915. 0.1915. That's the size of that area. And then for our second value is 0.55, which is that one there. So 0.2088. So now that I know the areas of those two parts, I can use that to work out the area of the red parts. So the probability that x is greater than 2.5825 and that x is greater than less than 2.4. Now this is the first time I've done this sort of notation. Normally it's one whole inequality, but because it's not a continuous group, you need to do it in two separate parts. Now to work that out, it's going to be 1 take away 0.1915 plus 0.2088, which equals 0.5997. So the last step 4, write the answer in context. So what that means is, so the probability of getting a weight that less than 4.25 kilos and more than 2.5825 kilos is 0.5997. So the key part of the question is finding those areas and taking them away from 1. You could also do it taking away from 5 in 2 parts. So you could take this number away from 0.5 and then add that to this number from 0.5, but you're really working out the same thing. And in fact, I think that's the way the workbook tells you to do it. Here's another example which you can have a go at yourself. So the length of a T-Rex tooth fossil is normally distributed with a mean of 20 centimeters long and a standard deviation of 1 centimeter long. What is the probability that a randomly selected fossil is less than 19.23 centimeters and more than 20.82 centimeters? So have a go at that. Pause the video and then come back and see how you got on. Okay, hopefully you had a go at that and you've got an answer. So let's have a look. So steps again, draw the picture. Okay, so there's our areas. So we're going to try and find that area from the table and that area from the table. First, we'll calculate the Z-score using the formula. And doing that calculation gives us minus 0.77 for the lower Z value. The higher Z value is 0.82. Step 3, find them on the table. So 7.77 gives us that number there. So it's 0.279 and 0.82. So 0.8 and 2 gives us that value there. So 0.2939. So we've now found the areas. So then our probability of x being less than 20.82 and x being more than, oh no, wrong way around, x being more than and x being less than 19.23 is going to be equal to 1, take away 0.2793 plus 0.2939. Which gives us 0.4268. So the last thing to do is write that answer in context. Probability of getting a fossil that is shorter than 19.23 centimeters and longer than 20.82 centimeters is 0.4268. So that's it. Hopefully that's the answer you got. So as always, it's the same steps as that you've been doing for a while. Draw a picture. If you end up with one that looks like this, calculate the z-score, look it up from the table, and then we just have to remember to take away from 1. So the probability of x being less than a value and more than a value is that. So head to the lesson page. There's some work for you to do there. Good luck.